Okay, back to our geometric sequences. Task 1. Here we have a bungee jumper. Jumps from a bridge. The table displays parts of a sequence that models the bungee jumper's maximum height in feet above the water during each rebound. Okay, so my bungee jumper is jumping off, fully extended. It hits this line, and then it's going to jerk back up. That's how bungee jumps work. Bungee jump works. So when it jumps back up, that maximum height above the water is 200 feet. And then he's going to bounce back down and then bounce up slightly less higher. So then he's going to jump up and only go 80 feet. And then he's going to bounce back down and back up to 32 feet until eventually he's just going to level out and just hang there, right? So, no, thank you. Okay, so what type of sequence is this? What is the common difference or ratio? So let's go ahead and let's look at what type of sequence is this, first of all. It is a sequence, first term, second term, third term. If we notice here, let's look at our consecutive terms. This one goes down by what, 120, 200 minus, so this goes down by 120. But then from here to here, that doesn't go down as far. That only goes down by what, 48? So I can tell it does not have a common difference. Okay, so I know it does not have a common difference, which means it is not an arithmetic or arithmetic sequence. So now let's look, can I multiply by the same thing? So that might be harder to see, especially on one that's decreasing. So I'm going to go ahead and dig my calculator out. And I'm going to take, here, let's bring my notes back up. Oh, not that one. Bring my notes back up. Okay. Ooh. Split view. Oh, maybe not. Sorry, guys, I don't know what's going on. There we go. Okay, and let's take that 80 and divide it by the 200. And so basically I take the 200 and multiply it by 0.4 to get the 80. And then what about the 32? 32 divided by 80, 0.4. So I take the 80 and multiply by 0.4 to get 32. So what type of sequence is it? I'm multiplying by the same amount each time, so that tells me it is a geometric sequence. And it's going to have a common ratio of 0.4, because that's what I multiply each term by to get to the next. I take 200 and multiply by 0.4, the 80, multiply that by 0.4 to get the 32. So what are the fourth and fifth terms of the sequence? Well, to get to the fourth term, I would need to take, so basically I'm extending this table out, fourth term, fifth term. So to get to the fourth term, I need to take the previous term, which is 32, and multiply it by 0.4. So 32 times. So again, I'm going to show you a cool calculator trick. I'm going to type in the first one, 200 times 0.4 gives me 80. Now, instead of typing in 80 times 0.4, I'm just going to type in times 0.4. So this takes the previous answer and multiplies it by 0.4. So if I hit enter, there gives me the 32. But now that I've done that, if I just keep hitting enter, it gives me my next term, which is 12.8. And then if I just hit enter again, it gives me my next one, which is 5.12. So there's the fourth term. So I would write it, f of 4 is 12.8, and f of 5 is 5.12. So there is the fourth and fifth terms of the sequence. And I can keep going and it'll just give me all the next ones. And again, I'm going to get really small because this is a exponential decay problem, right? Because I'm multiplying by 0.4 each time. So this is a exponential decay problem. It's exponential I don't think I spelled exponential right. Oh well, it's exponential decay.